Welcome to the lecture. In this video, we will learn what is NoSQL database and its features. The NoSQL concept was introduced by Carl Storch in 1998. So let us see one by one features of the NoSQL database. So here is the first feature of NoSQL database, that it is a non-relational. So NoSQL database refers to non-relational databases, means there are no tables with the fixed column records. It avoids joins and it is easy to scale. The another feature of NoSQL database is that some says that NoSQL stands for non-relational, while others say it stands for not only SQL. NoSQL databases stores data in a format other than the relational tables, but this doesn't mean that NoSQL database cannot store relational data. They just store it differently than the relational databases do. NoSQL databases are mostly open source. Some people say it's schema free or having dynamic schema. The data structure used by NoSQL databases are different from those used by default in relational databases, which makes some operations faster in a NoSQL databases. NoSQL database does not require a fixed schema, and it provides a flexible and extensible schema model. NoSQL database model doesn't have any fixed structure and it's flexible to fit in any form, so it is called schemaless. The NoSQL data model allow related data to be nested within a single data structure, so this is also one of the important feature of NoSQL database system. Next is distributed architecture. So NoSQL database systems are built over a distributed architecture. So the benefit of this is that there is no single point of failure. Mostly shared nothing architecture is used. It is horizontal scalable. So horizontal scaling means that you can scale or increase the capacity of system by adding more small machines which are having the commodity hardwares, whereas vertical scaling means that you scale by adding more powers to the existing system in the form of number of CPUs, or the RAMs may be increased to the existing machine. So vertical scaling, this approach was used with the traditional relational databases to increase the capacity, and which was very costly. A NoSQL databases includes the simplicity of the design, and it supports the simple horizontal scaling to the clusters of the machines with the commodity hardware, and provide the final control over availability. It handles big data. So best part of the NoSQL is that it can manage huge amount of data by adding more and more number of the machines in your cluster. So a NoSQL database system contains a wide range of the database technologies, and that allow you to store the structured or semi-structured or the unstructured and probably the polymorphic data easily. Next, it supports easy replication. So replication copies the data across the multiple servers. So each bit of the data can be found in multiple places. Data replication is a very important part of keeping the database up to date and serving the queries. So it is one of the way to guarantee the availability. So this is one of the important feature, that it provides the easy replication. One more important feature of NoSQL database system is it provides a simple API. So very simple APIs are used for the low level data manipulation and selection methods. It gives easy to use interfaces for the storage and querying data, and no standard query language is used here. Use of the simple, one of the benefit of this using simple API is that it makes possible for the web enabled databases running as internet facing services. Welcome to the next lecture. So in this video you will learn why NoSQL concept is introduced and why it is so popular. Relational databases continued to be dominating the computing world till year 2000, and during 2000 there was a distinct shift to the web services, where applications would communicate over internet, over the HTTP, and this was new form of the communication which uses or which requires more flexibility for the structure of the data which is being transmitted between the application. This data came in all the shapes and the sizes, structured. It is semi-structured, unstructured and polymorphic. So defining the schema in advance for such data becomes impossible. And if you try to communicate with the SQL, data must be structured, because this was a restriction of the SQL that it requires the structured data, and this was not feasible for the high performance interaction. So this was the one reason of evolution of NoSQL. The second reason is, as storage costs rapidly decrease, the amount of data application needed to store the data and to query that data increased. So as the number of user increases, there was increase in data, and to cope up with this increase, clusters of systems were used. Relational databases were not designed to run on the clusters, and no SQL database users can efficiently run on a clusters. It can run on a distributed system. The third reason is the third party sites like Google, Facebook, Amazon, etc. are you can see that they are generating the huge amount of data daily, and these sites has to define fast access to the data, and this requires to process the huge amount of data on a daily basis. The system response time becomes slow when you use the RDBMS for handling such a massive volumes of data, but NoSQL efficiently handles this big data. To handle the problem of RDBMS, you may think of scaling up the system by upgrading your existing hardware, but this process was expensive, and the alternative approach for this is to distribute the database load on a multiple host whenever the load increases, and this method is known as a scaling out. And NoSQL supports the horizontal scaling by increasing number of small machines with the help of the commodity hardware. So this was the one reason, the huge amount of data needed to be handled, and this was the limitation of RDBMS. And used with the help of the cluster, NoSQL can easily handle it. The another problem was the evolving nature of the software engineering approaches like agile development. So agile development was rising in a popularity, and core principle of the agile development is rapid adaptation to the changing requirements. So when requirements change, the data model also changes, and new data needed to be continuously stored in the database. This is a problem for the relational databases because the data model is fixed in a relational databases and they are defined by a static schema. So in order to change the data model, developers have to modify the schema, and these are ultimately slow down the development. And because it is time consuming process, and also because it impacts the others applications and the services. But by contrast, a NoSQL database fully supports the agile development. You can directly push the data in the database, as NoSQL has flexible schema or no schema. So these are the reasons that's why NoSQL systems was introduced to handle the unstructured, semi-structured data, to handle the big data, to cope up with the agile development, and to handle the problem of scaling. Welcome to the lecture. In this video, you will learn CAP theorem. CAP stands for consistency, availability, and partition tolerance. Let's look at the three system characteristics to which the CAP theorem relates. Consistency. Here, consistency means that all nodes in the network see the same data at the same time. Availability guarantees that every request receives a response even if one or more nodes of the systems are down. However, it does not guarantee that a read request return the most recent write. Partition tolerance guarantees that system continues to function despite some message loss or failure or part of the system. CAP theorem or Eric Brewer's theorem states that in network shared data system or distributed system, we can only achieve at most 2 out of 3 characteristics for a database, that is, only 2 from consistency, availability, and partition tolerance. A distributed system always needs to be partition tolerant. We don't want to make a system where a network partition fails the whole system. Therefore, partition tolerance is a property we cannot avoid while building our system. So, a distributed system will either give up on consistency or availability but not on partition tolerance. For example, in a distributed system, if a partition occurs between two nodes, it is impossible to provide consistent data on both the nodes and availability of complete data. Therefore, in such a situation, we either compromise on consistency or on availability. NoSQL databases are designed for distributed network application. Hence, a NoSQL distributed database is either characterized as CP or AP. CA type databases generally runs on a single node and don't provide distribution. Hence, they require no partition tolerance. Such systems are generally monolithic systems. This diagram shows the classification of different databases based on CAP theorem. CP database delivers consistency and partition tolerance at the expense of availability. AP database delivers availability and partition tolerance at the expense of consistency. CA database delivers consistency and availability. As depicted in Venn diagram, RDBMS can provide only consistency but not partition tolerance, while MongoDB, HBase and Redis can provide consistency and partition tolerance. CouchDB, Cassandra and Dynamo guarantee only availability but no consistency. Such a databases generally settle down for an eventual consistency, meaning that after a while the system is going to be okay. To summarize, there is always a trade-off between availability and consistency for NoSQL databases. Welcome to the next lecture. In this video, you will learn the different types of NoSQL databases. NoSQL databases are increasingly used in a big data and real-time web applications. The data structure used by NoSQL databases are different from those used by the default in relational databases, and this makes operations in such a databases faster. So the different types of NoSQL databases are key value stores, document databases, column family stores, and graph databases. So key value databases are a simpler type of database. Here data is represented as a collection of key value pairs such that each possible key appears at most once in the collection. Key value pair storage databases store data as a hash table or a dictionary, which uses an associative array as their fundamental data model. Each key is unique and the value can be a JSON, a binary large object, string, etc. Here in this example, name is the key and ARIA is the associated value of the name key. Similarly, designation is the key and manager its associated value. A value can typically only be retrieved by referencing its key. So this makes querying such a databases very simple. Some examples of key value store databases are Redis, DynamoDB, React. Key value databases are great for use cases where you need to store large amount of data but you don't need to perform complex queries to retrieve it. So common use cases include storing user preferences or caching, shopping cart. For example, in a shopping mall, information regarding a particular product is stored on the basis of a particular key. So when the product is scanned by the machine, on the basis of a barcode, all the information for a particular product is accessed. So next type of database is document databases. So document oriented NoSQL systems are very similar to key value pair database. The only difference is that the value that is paired with a key is stored as a document Each document is self-contained, which means no schema is required. This gives a significant degree of flexibility over the data you have. Documents can contain many different key value pairs or key array pairs or even nested documents. It stores the document in the form of XML, JSON or BISON. Document-based databases do not support the join, so it almost overcomes the problem of sharing the data across multiple nodes. It does not support relation. Each document is standalone. It can refer to another documents by sharing their key corresponding to the particular document. They can horizontally scale out to accommodate large data volumes. Some of the document-based databases are MongoDB, CouchDB, TerraStore, and OrientDB. Use cases include real-time analytics, e-commerce applications, trading platforms, and blogging platforms. This is the example of document database. So here the data which is stored in the form of the key value pair within this curly bracket shows the document. So here first name is a field, surname, mobile, location, these are the fields, and they have associated with values, like first name has a value Maya. So these are the type field values. You can store the numbers, strings as a value, or you can store the array of the values. Like here profession is an array which includes values finance, banking, trader. Here car is an array of sub-documents. So it includes the sub-documents. So this sub-documents includes the key value pair where fields are model, years and values. Next type of NoSQL database is column family store. So column family databases store data in a column families as rows. These rows have many columns associated with a particular row. Column families basically contains the group of correlated data which can access together. Here is what an individual row within a column family looks. A typical column family contains a row key as the first column, which uniquely identifies that row within the column family. The following columns then contain a column key which uniquely identifies that column within the row. So here the call A, call B, these are the column keys. Each row in the column family is not required to have the same number of columns. Here is how data in a table would translate to the column family. So for example, this is the table like your relational databases where each customer information is stored row by row. So it is stored in a rows and a column. This same information can be represented in a column family view like this. So here John Lennon is a row key of the first column family. So all these columns forms the column family, and these are the rows, multiple rows in the column family. You can see that each row in a column family is not required to have the same number of columns. In the first row there are 5 columns, while in a second row there are only 4 columns. So this definition is allowed in a column family view, but it is not accepted in a relational database system. Column databases are more scalable as compared to the other databases. They can be loaded fast. A table containing millions of rows can be loaded within a few seconds. We can start querying and analyzing immediately on this loaded data. Means it supports fast to load and query. Examples of the column databases are Cassandra and HBase. Column store database is popular among companies and organizations dealing with big data, IoT, and user recommendations and personalization engines, for example Spotify, Facebook. Next database is graph databases. Graph databases are ideal for representing complex relationships such as social networks, product preferences. Graph databases stores data in the form of nodes and edges, in which nodes are represented as entities and relationships in the form of edges. Relationships can be unidirectional or bidirectional. Adding new relationships to the graph database is easy, but changing existing relationship to the graph database is difficult task because changes has to be made on each node for each relationship in the existing data. The examples of some graph databases are Neo4j, OrientDB, FlockDB. You can say this is the example of the graph databases. So square boxes here represents the nodes. Okay, now here each of the node has a property, and that property is the name of a person. These two nodes are joined by the edges, which represent the relationship, and the direction of that relationship is represented by the arrow. This relationship is labeled. For example, the relationship between Anna and Big CEO is the employee, means Anna is employee of Big CEO. So you can label the relationship. A query on the graph is also known as traversing the graph. The relationship between nodes is not calculated at the query time, but is actually persisted as a relationship. So traversing persisted relationship is faster than calculating them for every query. With this structure, you can, for example, ask the query as find the books in the databases category that are written by someone whom a friend of mine likes. Now this is the another example. The properties can also be added to the edges of the graph database, which helps us to query the graph database. For example, here this three nodes are here, which are uniquely identified by the ID 1, 2, 3. Beside to that, they have two properties, name and edges. The relationship between these two nodes is bidirectional, and it is specified with the properties. For example, this relationship has a property with ID 100 label nodes since this is the date. So this means that Alice knows Bob since 10 March 2001. In this way, you can traverse through this graph. Now, use cases for the graph databases found where you need to traverse the relationships such as social networks, fraud detections, and recommendation engines. To summarize, we have studied the different types of NoSQL databases as key value pair database, column family database, document-oriented databases, and graph databases. Welcome to the next lecture. In this video, you will learn the features of MongoDB and the basic terminologies used in a MongoDB. So MongoDB is an open source cross-platform document-oriented database system that uses the concept of NoSQL. This is an open source product developed by the company 10gen in October 2007, and the same company also maintains it. MongoDB exists under the general public license GPL as a free database management tool. It also available under commercial license as of the manufacturer. Let us see the important features of MongoDB. It is schemaless. MongoDB is a document database in which one collection holds different documents. The number of fields, contents, and the size of the document can be differ from one document to another, and this gives the schemaless structure. The next feature is it supports ad hoc queries. So in MongoDB, you can search by fields, you can apply the range queries, and it also supports regular expression searches. The next feature is high performance. The input-output operations are very less in MongoDB as compared to the relational databases, and this is possible due to the support of embedded documents in a MongoDB. This improves the performance. The another feature available in a MongoDB is indexes, which helps for the faster queries. Next feature is high availability. So MongoDB provides auto replication that allows you to quickly recover data in case of the failure. A replica set, which is a group of MongoDB server, is created by the MongoDB and that maintains the same data on all the servers. So this replica set provides redundancy, which increases data availability. The next promising feature of MongoDB is horizontal scalability. MongoDB provides horizontal scalability and it is possible through sharding. So sharding distributes the data across a cluster of machines. Sharding is a partitioning of data and placing it on a multiple machine. So while partitioning data, the order of data is preserved. Next feature is rich query language. So MongoDB has a rich query language. It supports all CRUD operations like creation or creating the collections or database, retrieving the data from the database, update, delete operations. The query language also provides text search and aggregated features. MongoDB works on the concept of the collection and document. So following three terminologies are associated with the MongoDB: database, collection and document. So database is a physical container for the collection, and a simple MongoDB server typically has multiple databases. The another concept is collection. So collection is a group of MongoDB documents. It is equivalent to RDBMS table concept. A collection exists within a single database, and collections are schemaless, means documents within a collection can have different fields, and all documents in a single collections are similar in some manner, but they can have the different fields. The next concept is document. So a document is a set of key value pairs, and documents have dynamic schema, as we discussed earlier. So dynamic schema means that documents in the same collection do not need to have the same set of fields or the structure. So for example, this is a sample document in a JSON-like structure. Here data is stored in the forms of keys and value pairs. So the key in this sample documents are _ID, name, age, website and hobbies. Here _ID field represents a unique value in the MongoDB document. It is a 12-byte hexadecimal number, and this _ID field is like the document's primary key, which uniquely identifies this document within a collection. If you create a new document without an _ID field, MongoDB will automatically create this field and assign a 24-digit number to it. Now this given table shows the relationship of RDBMS terminologies with respect to the MongoDB. So the first one, database, this terminology is same for both RDBMS and MongoDB. Table in RDBMS is equivalent to collection in MongoDB. Tuple or row is equivalent to document. Column to field. Join is not available in a MongoDB, but relationship can be maintained by embedding documents within a document. MongoDB provides itself a default key and that is _ID, and which functions as a primary key. In relational databases like MySQL or Oracle, server is MySQL D or Oracle, where in a MongoDB it is MongoD. And for RDBMS, the clients may be MySQL or SQL Plus. For MongoDB, it is Mongo. To summarize, in this video, we discuss various features of the MongoDB database and the basic terminologies used in it. Welcome to the next video. In this video, I am going to show you how to download and install MongoDB on your Windows 10 operating system. MongoDB is free, open source, cross-platform document-oriented database. So let us see how to install it. Search for MongoDB in your browser. Click on the first link from www.mongodb.com. Once the website is open, click on Software tab. You will be able to see different options here. one we want to download and install is community server. So just click on community server. It displays the available downloads. So current version is 4.4.5, platform Windows, and package is MSI file. So select Windows and just click on this download button. This will start download of MongoDB MSI file. Once the download is complete, click on MSI file. Now you can see installation wizard. First you just need to click next. Then you need to accept the license agreement and then click next. Select complete from these two options as we are going to install complete version of MongoDB. Here you may see install MongoDB as a service. I will let this as default. So I will leave this checkbox click install MongoDB as service, then run service as a network service user, service name as MongoDB. It is going to create two directories. One is data directory and other is log directory. So all the stuff of your MongoDB database will going to be stored in this data directory. Just click on next. This next window will ask you if you want to install MongoDB Compass, which is official graphical user interface for MongoDB. Now I left this checkbox unchecked as I don't want to install it. Just click on next and then click on install. Now the installation of MongoDB has been started. After the MongoDB installation successfully finished, you will see this window, completed the MongoDB 4.4.5. Click finish button. Now go to the location where MongoDB is installed. So just go to C directory, then program files, and you will be able to see MongoDB folder here. Click on server 4.4. Now click on bin. Here you will find all the MongoDB related executable files. To start MongoDB, you need to run this file, which is MongoD. So double click. It successfully has run and your MongoDB service has been started. In order to run MongoDB client, you need to run this file Mongo. Just double click. At the bottom of this, Mongo shell is open. From here, you may run your query. To display all the databases available in a MongoDB, type command show DBS. Default databases will be displayed here. So your MongoDB is successfully installed on your Windows 10 system. Welcome to the next lecture on creating database and collection. In this video, you will learn to create database, drop database, create collection, drop collection. Let us start MongoDB client. First run MongoDB server, then run Mongo client. A command prompt will appear. To create database, type use command. The command will create new database if it does not exist. Otherwise, it will return the existing database. If you want to create a database with name myprojectdb, type the command as use myprojectdb, enter. It will display message switch to db myprojectdb, means you are now in a database myprojectdb and myprojectdb database is successfully created. You can also type db command to check in which database you are currently. To display the list of databases, type command show dbs. It will display the list of databases available. Now we will see how to drop database. db.dropDatabase command will delete the selected database. So first switch to the database that you want to delete. For example, to delete myprojectdb, first switch to myprojectdb, then type db.dropDatabase. It gives the message myprojectdb is successfully dropped. To check, type show dbs. myprojectdb is not exist in a given list as it is deleted. Now let's see how to create collection. To create collection, type the command db.createCollection with the name of collection as my collection. Press enter. My collection is created. To check, type the command show collections. It will give list of the collection available in a current database myprojectdb. Now it is showing only one, my collection. In MongoDB, you don't need to create collection. MongoDB creates collection automatically when you insert document. For example, Type the command db.book. Type the command db.book.insert within parenthesis key value pair with key title and value Java programming. It will insert a document with one key value pair in a book collection. To check, type command show collections. So book collection is added in a previous list. To drop collection, type the command db.name of the collection dot drop. It gives value true. This indicates book collection has been dropped. To check, type the command show collections. Book collection is removed from the list, indicates it is deleted. Welcome to the next session. In this video, you will learn data types and inserting document using insert one method, insert many method. So in MongoDB, data representation is done in a JSON document format, but here in a MongoDB, the JSON is binary encoded and which is called as a BSON. And BSON has a rich set of data types. This data type shows you what type of information can be stored in a database. I'm explaining it in a form of a key value pair for the sake of explanation only. So the first is integer. Integer data type used for storing the numerical values, for example 203. Then double stores the floating data value like 65.786. String stores the text data and it is one of the most frequently implemented data type for storing the data. Boolean for storing the true or false values. That is implemented for storing date and time. For example, you can create a date using new date, and in a parenthesis you can specify the format like 4 digits for year, 2 digits for month and 2 digits for day. Array stores a list of values under a single key, and this list of values are enclosed in a bracket, square bracket. You can create an array of integer value, floating point values, or the string values, or even array of object. Now object, it is implemented for the embedded document. So here you may insert the key value pairs in a curly brackets which represent a document or object. Then object ID, it stores the ID of the document which uniquely identifies this document in a collection. Object ID can be provided by the MongoDB implicitly when you insert any document in a collection, or you can explicitly provide the ID for the document. No value can be represented by the null. So these are the data types. Now move towards how to insert the document in a collection. So switching to my command prompt. First let's see which databases created earlier. So type the command show DBS. It will show the list of the databases. So MyDB database we have created earlier. We can insert a collection, new collection in a MyDB. So for inserting a document in a MongoDB, you first create a collection in a database and then insert the document within a respective collection, or you can directly put an insert statement. So for inserting document, either you can use insert one method for inserting a single document, or you may use insert many method for inserting multiple documents at a time. So let us see how to use insert one method. So type db.name of the collection students.insert1. Here you have to specify the document in the form of key value pair, like name of the student as Alex, the another key value pair which represents the another attribute, for example stream may be science. Next is grade in CGPA. This is the floating point value. Then press enter. So here we have inserted a document which includes 3 fields whose values are represented in the form of a key value pair, like name is Alex, then comma, the another field or the attribute is stream and its value is science, and CGPA, it is a floating point value and it is 5.6. So it is showing that acknowledgement true means this record or this document is successfully inserted in a collection students. If the student collection is not available in your database, it will be created first and then this document will be inserted in that collection. Now here you can see the object ID is given. This object ID is generated by the MongoDB itself. We didn't have provided it earlier when we inserted this document, but MongoDB has generated it for this document so that this document can be uniquely identified within a student's collection. You can display this information using the find command. So type db.students.find. This find command will retrieve the document from collection student. So we have inserted only one document in a student's collection, so it is displaying it with now a new underscore id is a new field which is inserted by the MongoDB, which shows the object id, and we have given the information like name, stream and CGPA earlier, that is also visible here. So you can insert multiple documents at a time using insert many function. So how to use it, let's see. So db.students insert many in bracket. Now here you have to specify more than one document. So these more than one documents are inserted to the insert many function in the form of array. So you have to specify array, then enter the first document in a curly bracket like name bin, its stream is science and its CGPA is 6.7. Close the curly brace. So this is your first document. Then enter the second document, open the curly brace, name as Maya, stream for example engineering, CGPA 7.8. Here now I have added one more extra attribute, and that is awards for the student Maya, and this awards is actually the array of string type values. So Maya has got the two awards, best students and best sports person. MongoDB provides flexible schema. It allows you to add more attributes in a document, and it is not compulsory that each and every document must have same number of attributes or same numbers of fields. For example, here when we insert the first document whose name is Ben, here only we have considered only three fields, name, stream and science, but for the student Maya we have added the extra field as awards. So this is allowed it in a MongoDB. So just press now enter. Okay, so this message indicates that we have successfully inserted two records or the two documents in a student's collection, and MongoDB has generated object ID for these two documents that are displayed over here. You can also explicitly insert the object ID when you are entering a document in a MongoDB database. For example, we insert one more record in this database, Ria, whose stream is science and whose CGPA is, for example, 8. Now, if you want to specify the object ID explicitly, then add one more field here, underscore ID, colon, and specify the identifier, for example 3. So I have added here the extra field which represents the object ID. So MongoDB will create an object ID 3 for this particular document instead of implicitly creating the object ID. Okay, so the record is successfully added in a student's collection. Let's display these records. Type the command db.students.find. To beautify the output, we can use the method pretty along with this find method. So this is the document which gives the information of student Alex. Second document gives the information of Ben, and third document gives the information of Maya, and this one fourth document that we have inserted just now, and explicitly we have provided the ID for this document, and that is 3. Okay, now you can check that for the earlier 3 documents, we didn't mention explicit object ID while inserting this document. MongoDB has generated the object ID for these 3 documents, and this is the object ID for which we have provided for this 4th document. Okay, to summarize, MongoDB provides the flexible schema, and so it is not compulsory that each of the document must have the same number of fields or the same number of attributes. You have the flexibility to add more attributes for documents. Welcome. In this session, you will learn to retrieve documents from collection and use of query operators for conditional retrieval. Find method is used to query documents from collection. So for example, type the command db.students.find. This will retrieve all the documents from students collection. So students collections have total 5 records. So all the records are displayed over here. For conditional retrieval, you may specify selection criteria as a parameter to find method. Selection criteria is written in the form of key value pair. For example, type the query db.students.find in bracket, specify selection criteria, for example, stream science. It gives all documents where stream is science from student collection. Total 3 documents where stream is science are retrieved. To query the documents on the basis of some conditions, you may use following operations. The first operation is equality operation. The syntax is key, and in the value part you have to specify the query operator $eq colon the value that you wanted to match. $eq is not compulsory. You may specify key colon just a value here for equality comparison. For example, db.student_find in bracket, name is key here, colon value is Ria. The equivalent of this query in RDBMS is where clause name is equals to Ria. So it will search all the documents where name is Ria. Other comparison operations that you may use are less than equals, greater than and greater than equals. The syntax are $LT is used for less than, $LTE used for less than equal to, $GT is used for greater than, and $GT used for greater than equals to. So for example, if you want to retrieve all the documents from the student collection where percentage are less than 50, then you may write the query like this: db.stud.find in bracket key value pair. So here key is percentage, so percentage colon then query operator $LT 50. Similarly, you will write the query for less than equal to, greater than, and greater than equal to. This is the comparison operator not equals. So you have to use the query operator $any for not equal to. To select specific values from a given list, you may check that values in an array. So the syntax is key colon, use the query operator $in colon. Here you have to specify the array of the values in which you want to search. So for example, you may write a query db.stud.find in bracket key name. So find the name in the array of values Rolly, Shirin, Susan. So for this you have to use here query operator as $in. So it is equivalent to where name matches any of the values in Rolly, Shirin and Susan. Let's see the example. To show all the students with CGPA greater than equal to 6.7, you will write a query as db.students.find in bracket. Now here key is CGPA, and for value you may write $GTE for greater than equal to, and value is 6.7. So it gives all the documents where CGPA is greater than equal to 6.7. You can check the values here. Now let's see how to use logical AND operator. So the syntax is db.collection.find in bracket. You can specify the query operator $and colon. It is array of the key value pair. So key 1 value 1, another pair key 2 value 2. So it will give all the documents from the collection where both these conditions are true, that is where both key value pair matches. Another operator that you may use for conditional retrieval is OR logical operator. Syntax is db.collection.find query operator $OR colon, then in a bracket you can specify the key value pair. So it will give all documents where either of this condition is true, that is either of the key value pair matches. Third is logical NOT, and the syntax is db.name of the collection dot find in bracket $not colon in square bracket you can specify the key value pairs. It will give all the document except those specified in an array. Welcome to the next session. In this session, you will learn to delete single document from database and deleting multiple documents from the database. To delete single document from the database, you may use delete one method. Syntax for the method is db.collection.delete1. This method deletes at most a single document that matches a specified filter, even though multiple documents may match the specified filter. Next method is delete many. The syntax is db.name of the collection.delete many. This method deletes all documents that match a specified filter. Or you may use remove method to delete records. The syntax is db.collection.remove. This will delete a single document or all documents that match a specified filter. Let's switch to the command prompt. Let's switch to our database MyDB. So type use MyDB. Let's see the collections which are stored in a MyDB. So type command show collections. There are two collections in MyDB database, products and students. Let's see the documents stored in a students database. Type the command db.students.find. Total 5 documents are displayed over here. Now let's delete the document where stream value is science. So you may write the query like this: db.name of the collection student.delete1. Specify the deletion criteria within bracket. Deletion criteria may be specified in a key value pair. Here our criteria is we want to delete the records where stream is science. So put the key as stream here, value science. One document is deleted from the database. Let's display the records of students collection. Here see that one record with ID 1 is deleted where stream was science. If you observe the student database, there were total 3 records where stream was science, but only the very first record where stream is science is get deleted, and that is with ID 1. Now let's delete multiple documents using delete many method. So type db.name of the collection.delete many. In bracket you have to specify the deletion criteria as we have specified earlier. We consider the same deletion criteria. Now currently in a database total 4 records are there. Out of these 4 records, these 2 documents are having a stream as science. So it is expected that these 2 documents will get deleted. So it is showing that 2 records are get deleted. Let's check the output. You may observe here that the record with ID 3 and ID 5 where stream is science are deleted. So in this way you may delete multiple records using delete many query. Now let's see how to use remove command to delete single or multiple documents from the collection. We will display the records available in our product collection. So type command db.product.find. So in products collection, total 5 records are available. We will remove record where the quantity is less than 40. So type the command db.products.remove. In bracket here you have to specify the deletion criteria. So deletion criteria is quantity less than 40. So the key is quantity. It is qty here colon. Now less than 40. So here you have to specify the expression. Again it will be represented in the form of key value pair. So open the curly brace, $LT represent less than colon 40. This expression represents less than 40. Here our deletion criteria is completed. Complete the brackets. If you want to delete a single record instead of deleting all the records where quantity is less than 40, here you have to add the second parameter. So second parameter to the remove function is just one flag. If you set this just one flag to true, this indicates that you have to delete only one document who fulfills this deletion criteria. And if you didn't specify this just one flag, or you specify it as a false, then by default all the records who fulfills this deletion criteria are get deleted. So when I say true here, it will delete only one document, that's very first document where quantity is less than 40. Only one record is removed. Let's see the documents remaining in a products collection. If you observe, so in a products collection, total number of documents where quantity is less than 40 are 1, 2 and 3, but only one document is deleted, and that is the very first document with ID 10. If you want to remove all the documents where quantity is less than 40, then you may write the query like this. So it will delete all the documents where quantity is less than 40. Okay, so it is showing total 2 documents are get deleted. Let's see the result. If you observe, before filing this query, there were total 2 records where quantity was less than 40. Both of these records are get deleted, and in a result you will find only 2 records where quantity is greater than 40. To delete all the documents from the collection without specifying any deletion criteria, you can type a command like this. This command will delete all the documents in collection product because we have specified the deletion criteria as empty. So all the 2 records from products collections are get deleted here. Let's display the records from the production collection. Okay, it is empty. Thank you. Welcome to the next session. In this session, we will learn to update document. Here we will learn to update a single document and to update multiple documents in a collection. First method is update one. The syntax is db.collection.update1. This method will update at most a single document that match a specified filter, even though multiple documents may match the specified filter. Then we will see the second method, update many. Syntax is db.collection.updateMany. This will update all documents that match a specified filter. Next method is update. Syntax is db.collectionName.update. It will either updates or replace a single document that match a specified filter or updates all the documents that match a specified filter. Let's demonstrate all these 3 methods. Switch to the command prompt. Switch to MyDB database. Consider students collection has 5 documents including fields _ID, name, stream, CGPA and rank. Let's update CGPA and rank of student who belongs to science stream. So type query db.students.update1 in bracket. Here you have to specify the filter or selection criteria. Our selection criteria is stream equals to science. So specify it in a key value pair, stream : science. Second parameter to this function is update statement. So type bracket $set : CGPA 6.5 rank 2. To update document, MongoDB provides update operators such as $set to modify the field values. $set will create the field if the field does not exist. This update one command will update the first document where stream equals to science. So it's showing update one command is successfully executed and it has modified one record. If you observe students collection, there are total 3 records including stream as science with ID 1, ID 3 and ID 5. But in result, only one record is modified, db.students.find. Here you may observe that students collections have 3 documents where stream is science, but only first document out of these 3 is updated. So the first document is with ID 1 where stream is science and its CGPA is updated with value 6.5 and rank as 2 that we have mentioned here in our update query. And rest of these 2 documents with stream as science didn't get updated. Now let's update rank of all students having CGPA greater than 6.5 to 1. Type the query db.students.updateMany. Selection criteria CGPA greater than 6.5 $GT : 6.5. Second parameter update rank to 1. So $set rank 1. It is showing that 2 records has been modified. Let's check the output db.students.find. So there are 2 records where CGPA is greater than 6.5 and that is with ID 2 where name is Maya and the second document is where name is Alex. For both of these documents, rank is updated to 1. So using update many method, you may update multiple documents at a time. Now consider products collection with fields underscore ID, item, color and quantity. Let's use update method to modify color and quantity of item small box. So type the command as db.products.update in bracket selection criteria item is equal to small box, and then update the color and quantity. Set color to black and quantity to 60. Okay. Only one record is updated. Let's check the output. By default, update method will update a single document. So here only first document with item is equals to small box is updated, and this second document who is having item as a small box didn't get updated. So to update the multiple documents, you need to set a parameter multi to true in update method. So type the query as db.products.update in bracket item small box set color to blue. Now here you have to add the third parameter multi is equals to true. This third parameter will allow to update multiple documents at a time. So this query will set the color of all small boxes to blue. So it is showing number of documents modified equal to 2. Let's check. Okay. So these two documents where item is small box and color is updated to blue. So in this way you may use the update method for updating multiple documents at a time by setting the multi attribute as true. Welcome to this session. In this session, you will learn to sort documents. To sort document in MongoDB, use sort method. To specify sorting order, 1 and -1 are used. 1 is used for ascending order while -1 is used for descending order. You need to use sort method along with find method. Let's consider students collection. It includes total 5 documents. To sort all these documents by name, write the query as db.students.find.sort. Specify in sort parameter the field to sort by as name : specify here value 1 for ascending and -1 for descending. 1. It will display the documents from students collection sorted by name in ascending order. You may observe here all the documents are sorted alphabetically by name in ascending order. To sort in descending order, type the query db.students.find.sort in bracket name for descending order -1. You may observe here that all the documents in student collections are sorted in a descending order, in a descending alphabetical order by the name. Now let's sort by stream field db.students.find in bracket specify the field to sort by stream in a ascending order. Now all these documents are sorted by stream. Here you may observe that documents containing the duplicate values for the stream field, like there are 3 documents with the science as stream. To achieve a consistent sort, add one more field which contains unique values to the sort. So let's sort on both stream and name field. So you may add one more field here, and that is name. Suppose again with ascending order, or it is better to use underscore ID field if you want a consistent sort. Now you may observe that just compare the previous result and this result. So here the documents where stream is science are, first document is Ben, Alex, and then Shirin, and here it is sorted as per the name as well, Alex, Ben and Shirin. So in this way you may sort documents in a MongoDB.